Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before or even considered taking up programming. Today we will look at the uses for multi-dimensional arrays. So, multi-dimensional arrays, what are they good for? Well, absolutely everything. Let us first look at a single-dimensional array, which is ideal for looking after a list of things, in this case, a list of employees. In this example, we're only storing one piece of information in the array, which is the first name of the employee. We can easily define or dimension our array to hold these four pieces of information like this, noting that this is an array of string data. By using the dim command word followed by the name we wish to give the array, then range of dimensions of the array. In this case, one dimension from elements 1 to 4, all of which are to hold string data. But arrays can do so much more. Let's look at a scenario where you need to store information in a two-dimensional array, for example, a chessboard. The board has 8 rows and 8 columns, which we can define as a two-dimensional array. Each of the cells or elements of the array can be addressed by the row and column positions, and data can be added to that location. For a chessboard, this type of array does very well, as each piece is either on the board or, when taken, removed from the board. In the game of chess, the chess pieces neither degrade as they suffer damage, nor travel on anything but a level plane. So there is no additional information needing to be stored. So we reference the position of the black knight as row 1, column 7. What if we needed to keep track of a third dimension, say for example height above ground? Our array would now be dimensioned with 3 parameters, giving the number of rows, columns, and height. So any reference to the array would need all 3 parameters to identify the location of where the data was stored. It's rare to have a need for more than 3 dimensions. However, PowerBasic will allow you to have up to 8 dimensions, assuming that you can keep your application and data within the 2 GB limit for a 32-bit application. Other languages can support more dimensions, and if your compiler is 64-bit, you can go beyond the 2 GB limit. Though you should really think carefully about needing more than 3 or 4 dimensions. So what kinds of data can you store in an array? Firstly, strings, either dynamic or fixed length. Numeric, all types of numeric data, floating point, integers, long integers, double words, quad integers, and 2 types of currency. User-defined types, possibly the most flexible of all and may eliminate your need for large numbers of dimensions, as each element of your array can contain a combination of variable types. So how would we create an array of user-defined types, or UDTs? Firstly, we need to define the UDT. Let's create a user-defined type called vehicle that holds information on a car or automobile. This type could be expanded to cover more aspects of a vehicle. Next, we can dimension an array to hold 100 automobiles as the vehicle type. Then we can populate the first element of the array, setting the value of each part of the UDT. With meaningful names for each part of the user-defined type, and also the name of your array, then the code can be easier to understand and therefore to maintain. Arrays are also used within matrix algebra calculations. The MAT command in PowerBasic can be used to perform operations on arrays, allowing you to literally delve into the world of matrix calculations. When it comes time to save the data you have in your array, you have some options. You can save the data to a file, either using a binary method, saving the entire array as one block to the file, or in a sequential method where each record in the array is saved separately. Alternatively, the array could be saved to a database as a series of records, allowing your application to read and update them in any sequence required. So, in conclusion, you will find that arrays of one or more dimensions can be a very useful method of both storing structured data within your applications and allowing it to be manipulated. In many cases, it saves the developer the time and effort of writing a lot of extra code to handle complex data. Hopefully, you'll find uses for these concepts in your own applications, but that's it for today. Thank you for watching.